morning, guys. Today we're going to be starting section 1.5, so we're going to be working with rewriting literal equations and formulas. So let's kind of rewind and look back at what we've been working with so far. So far, we've seen equations. Like this. So we've seen something like 2x plus 5 equals 9, or something like this. 3x plus 7 equals x plus 21. Notice in both of these equations, we only see one variable x, whether it's all on one side or an x on both sides of the equation. These are the types of equations that we've been solving and that we've been working on our skills with. Today we are going to start working with what we're calling literal equations. So today we are working with literal equations. And what a literal equation is, a literal equation is an equation that has two or more variables. So again, a literal equation now has two or more variables. So what an example of what that looks like is maybe 3y plus 4x equals 9. So see here we have a y and an x in one equation. Today we are going to be learning how to rewrite these equations and solving for equations, meaning we want to isolate one of these variables on one side by itself and everything else and the other variables on the other side. So let's look at our first example to see what that looks like and how to do so. So we're going to solve the literal equation (3y plus 4x equals 9), and we're solving it for y. Now what you guys can do when we're practicing this is when we know what we're solving for, what variable, you can make a habit of circling that variable so that you remember what variable you're solving for. What I'm going to do to keep track of it is I'm going to rewrite this equation, but I'm going to go ahead and write the variable I want to solve for in a different color. All right, so we have 3y plus 4x equals 9. Now before I continue, I want to show you guys how the structure of this equation is very similar to equations and the structure of the equations that we've been working with so far already. And I'll show you guys how. So let's take a look at this equation, maybe 3y plus 3 equals 9. If you guys notice, the structure of both of these equations is 3y plus some term equals 9, and 3y plus some term equals 9. The only difference is the difference in what that term is. So we're used to seeing this term as being a constant. Now we're just having a term that's a constant times a variable. So just how we would solve this equation, how our next step would be to subtract 3 from both sides. We're going to do the exact same reasoning, and we're going to subtract 4x from both sides in our literal equation. Looking back at our old equations, our one variable equations, this would leave us with 3y equals 6. In our literal equation, this would leave us with 3y equals, now since 9 minus 4x are not like terms, we cannot combine them. So we are simply left with 9 minus 4x. And remember guys, whenever we see a constant and a variable right next to each other, that means multiplication. So to keep isolating our variable y, I'm going to go ahead and divide both sides by 3, since division will undo this multiplication. So 3 divided by 3 is 1, leaving us with 1y equals, and nothing on the right side can be simplified, so we are left with 9 minus 4x divided by 3 as our final answer. Again, we know that we're done solving for y because we have y isolated on its own on one side with the rest of our terms and our other variables on the other side. At this point, you guys can go ahead and pause the video and leave in a comment down below what you think a literal equation is. Now that you've left your comment down below, let's go ahead and look at a second example. So for our second example, we're going to solve the literal equation y equals 3x plus 5xz, and we're solving it for x. Again, to remember what variable we're solving for, we can go ahead and circle that variable. What I'm going to do is I'm going to go ahead and rewrite this equation, and I'm going to write our variable that we're solving for in a different color so it stands out to me. So 3x plus 5xz. Now I want you guys to notice how our first term and our second term both have an x, almost as if they share the same x. So we've heard that word share before when we were talking about distributive property. How when we have, so for our distributive property, when we have an x times 6 plus 3x maybe, remember we are going to share that x with both terms. Similarly, because both terms share an x, it's almost as if we can take them away from both of them also. So it's kind of like the opposite of distributive property. So I'm going to go ahead and take out these x's from both terms. What that's going to leave me with is the x that I took away from both terms times the terms that I shared the x with. So that would give me a 3 plus 5z. And remember guys, when we see a variable outside of a parentheses or a grouping symbol, that always indicates multiplication. So that means there's multiplication happening right here. So to keep isolating our term, we want to undo that multiplication, meaning we want to do the opposite operation or the inverse operation. And in that case of multiplication, the inverse operation would be division. So just like how we have, if we had y equals 7x, which is multiplication, to undo that we would divide by 7, correct? In this case, our 7 is just going to be our 3 plus 5z. So we're going to divide both sides by 3 plus 5z. Again, these are going to cancel. So we are left with y divided by 3 plus 5z equals x. Or if we're not comfortable with the x on the right side, we can rewrite it as x equals y divided by 3 plus 5z as our final answer. Again, the reason we know that we are done solving the literal equation for x is because we have x isolated on one side by itself with all of our other terms and our other variable on the other side. You can go ahead and rewind and rewatch this video as many times as you need. If you have any questions, you can go ahead and let me know.